Good morning.
Morning.
Well, that was good. It's been a while since we've been here, so a lot's happened at the site since our last meeting. I want to take a couple of minutes to go through where we were, some of the aspects of what went in, and I want to remind everyone more than anything, this is not an erector set. Okay, it's not like when you go to Home Depot and all the parts are fit and you just put it together. This is a project you're continually bobbing and weaving. This is doing projects that have never been built before. So things come up. And part of the challenges we have is dealing with those things that come up. I'll go through a couple of them and you'll get the idea of what I'm talking about. So when we left last time, we just started the pool. We were getting engineering on how to continue with the pool. We were just putting in trusses, bar joists on the upper floors. We had just poured the deck, and the windows were not yet in. So let's start off. Okay, so hold on. So if you look here, we'll go into, I want to go over a couple of things. If you look in your little handout I put in front of you, you'll find this. Okay? This is an engineered drawing approved by the pool engineer that tells them how they're going to build this. We have a drawing in the set from the civil engineer, we have a drawing from the structural, but we don't have anybody that says how we actually build the pool. What supports it, how it's assembled, how the plumbing works. This is a separate permit, and this is something that you have to get before you start, okay? The issues with this were, you see this wall right here, what's actually going to support that pool? You can't just sit it on the dirt. We had planned early that the piles that were installed here would sit directly under that wall, so when they built the pool up, that wall would support. And if you look at this drawing, which I've distributed, you'll see a drawing that shows piles. You see here, the piles are all placed as per that drawing. Two of these are squares. The reason these are squares is because when we actually put the piles in the ground, we didn't have elevations on any of these. So these were extended up with a drawing approved by the engineer. Okay, at this point, we're just getting the rest of the shell going. We've got the plumbing coming through into the house. We've got the plumbing running under, the equipment under the stair. You see the floor drains are in place, and those are all sealed going through the house at the time and out to the exfiltration fields, and things are moving along. Okay. Okay, stop for a second. You guys know when we do the lower level of the house, we put matting. Pool is very similar. You're building a complete structure. Okay. Unlike a house, you're not pouring forms, okay? You're putting up barriers and you're going to shoot with Gunnite. You guys who've never done this, Gunnite's a cementitious material that gets sprayed and troweled, okay? You'll see that in a second. Okay, hold it a second. You see here, you're shooting the Gunnite with a spout, okay? The truck comes, it's mixed in a truck, it's put it under pressure, and they shoot it, and they form it. There are no quote-unquote forms in doing a pool like you do when you do a house. Okay, the pool is shot, and in this case, there was a whole concept of exactly how we're going to do this wall. Because on this wall, you can shoot it directly up against the form. On this wall, it's floating. So we actually had to put form up, shoot half, take the form off, shoot the other half. Okay. Look, this is very loose, okay? This is polished on site, it's formed with a trowel. They always do the walls first, do the floor last, because this will all run down. There's no sense in doing the walls, doing the floor first, because when they do the wall, they're just gonna have to scratch it out. You see this guy is setting levels. All right, hold it. Okay. Everybody look and you'll see this one. Okay? And this is partially what I was talking about when I said erector set. Okay? I printed one of these out, and this is actually, in real life, about 50 pages long. Every number you see on here represents a truss. Okay? And if you look at this on your drawing, can I see those for a second? For some reason mine. Okay, everyone represents a truss, and there'll be a sketch in the drawing that shows each one of these trusses. Gives it a design, gives it a length. Okay? The engineer is going to provide, the truss engineer is going to provide you with a stamped, signed engineering drawing with these trusses. This is why I say this is not an erector set. We got the full set, and it was wrong. Because when we went and we measured in the field, versus what we had on the drawing, they were off by 6 inches. Okay. Contractor didn't check it, we checked it. Had we not corrected it, they, instead of sitting on a post, they would have just fallen down. Okay? This actually took 3 revisions to get correct. Okay? This is why it's very important in the field that you don't just take everybody's word for it. You verify, you check. They came based on this, and we were handed this sketch that said, oh, this is perfect, it's all right. No, it's not. Okay? So, big field, we were lucky enough to have a CAD file. We started with dimensions on the CAD file to see what the overalls were, and later we went back and checked it in the field. Okay? Not everything you get, whether it be trusses, whether it be bar joists, whether it be anything, nothing has ever been done before. It's not like this is mass produced. Like if you're building a tract home, they build 50 of them. You know exactly what you're going to come up with because every home is exactly the same. If you've ever been on a site where they build tract homes, the guys show up, they don't even look at the drawings anymore. This house has never been built. You cannot take the word of someone that these and everything in this house is going to be correct. You have to be proactive. You have to feel verified. Okay?
So between CAD and field, there's 6 inches off, right? And trying to maintain a project timeline and schedule, at what point did you actually execute the actual production of those trusses?
We got these, when you saw the previous drawing, the previous photo, when we first started, before the windows went in, we were already into this, okay? You have to plan this in the point so when you're ready to when you get to the point where these are ready to go in, they're there. If you look over here, when they're doing ply beams at the top, they actually put in supports that are going to receive these trusses. So it's important that the drawings match what's there, okay? So if you see here, trusses are in, plywood sheathing is going on. Hold this way. Sometimes when you look at these drawings, you'll see things like this that you're like, what the hell is that? Okay? You have to understand the drawing. Okay? Take your time when you get a truss drawing. Look at the plan. Look at the architects. Look at the rendering. Make sure these all work. One of the things Devin and I came across is when this all went in, some of these valleys at the end weren't at the right height. They had to be built up or they wouldn't pitch. Some of them had to change because we needed to put drains in. The scuppers that go through on the drawing is a beautiful scupper. Code says that a roof cannot hold more than 4 inches of water. So from the pitch of the roof from the drain up 4 inches, there needs to be a scupper or a secondary drain. Problem is when you got to that point, you were in the middle of a beam that you weren't allowed to cut. So go back to the structural engineer, go back, come up with a plan with the roofer, get it verified by the structural engineer. It's a process. So again, you have to understand it, you have to review it, and you have to see what the issues are and come up with ways to solve it. Yeah? Yeah. These are the scuppers. Tin tap. This is the first means of waterproofing on a roof. Okay? This is Belt, bar bedroom, tin tab, fasteners. This requires an inspection before you go any further. Okay. This case, this happened to be a terracotta tile which was glazed like a tile would be in a bathroom. When you're putting tiles in Florida, they don't nail every tile. And there's a really good reason for it. Most of these are put in foam. Spray foam comes down. What they found was when they put nails through the holes to nail them on, and then you get a hurricane, they shake. And when they shake, the nail holes start to creep. The tiles start to break. When they foam them, they don't move as much. They don't break as much. So there's every manufacturer will tell you nail third course, second course, fourth course. This one, I don't remember if they said all of them, which is partial. But you have to make sure you understand how to go in. The barrel tiles we all see, they're mostly put in with foam, and like every third or fourth course is nailed. If not, every time you have a storm, it's going to shake a little more, a little more, a little more, and it's going to go. But you have to understand that this isn't totally the waterproofing that's keeping your roof dry. Keeping your roof dry is what's under that. Good. You can hold this up. Okay. Parapet walls. You have to make sure when you're doing a house in stucco, the parapet walls, that they are waterproofed before you stucco, because stucco is not a waterproofing agent. It'll hold it for a while. In a year, you're going to start getting leaks. You're not going to know where they're coming from. Also, there's a flashing that runs up. There's actually a stucco stop made just for that application. Make sure they use the right one. Okay. This wall's been stucco. When you stucco a wall, it's not a one-part process, it's a three-part process. First, the wall has to be completely waterproof. It has to be dried. Again, the stucco is not the waterproofing membrane. Once the stucco is put on scratch coat, finish coat, whatever, and there's many different types of finish. Both the steel trowel, which is like glass, which we hate doing because it's really a pain in the neck and never works right. Excuse me. Standard flow goes in. Give it time to dry. You have to prime it. If you don't prime it and you let it just sit, it's going to start cracking. Okay, they'll tell you different amount. Common frames, 3 weeks, 2 weeks, a month. Painters also have a hot oil primer that they use sometimes that you can put on earlier. Make sure before the scaffold comes down, before you leave that side, you've made arrangements with your painter to prime it. Okay, hold on. The dock. This dock's 150 feet long. Okay? Docks is set up. There's a guideline. The DEP and the EPA have a height of how deep the water can be at the end of the dock. Okay? Some of the docks in Manalapan you'll see are very short. They're like 10 feet off the wall. Other ones come out 150 feet. The difference is what determines it is the depth over here. Okay? Before you go, you'll get a bathymetric survey. It'll tell you the water depth at different points. That's going to determine how far out this has to go. This dock is a typical dock we build, standard piles at the bottom, deck, power's coming through. You see the hose, this is all for water. When you're doing this, you have water, you have power, you have pedestals that are going in, you have water, you have lighting going in the posts. You'll see pipes sticking up. You'll see conduits running down. We try to put all the conduits and all the piping in the pour of the dock. Stays protected, doesn't crack. Sometimes we have to go underneath, depends on what it is. You want to have this all worked out ahead of time, because when this guy comes out to do this, he's got a big setup going. If he has to stop, so we're waiting 3 weeks for an electrician to come in, it's going to be a problem. Okay. Okay, hold it. Okay, so at this point, the dock's poured. The forms cement and pierce, and the windows are going in. Now, everybody remembers in the early classes here, thank you. We had the shop drawing. These are the shop drawings we went over probably in the second class. Every one of these was an explanation of how these go in. For example, this door right here, which is hard to see, is actually this door right here, okay? When you're doing this, you're not always gonna have the perfect condition. This is construction. Sometimes it's off a half inch, sometimes it's quarter, sometimes it's perfect. And sometimes you wind up with issues like we had over here, where you don't have a solid member to go into. On this side right here, this is a long set of sliding doors. There was a block at the end, and every light, every window has an explanation of how it goes in. Every manufacturer gives you an NOA, tells you how it's to be installed. You cannot install into loose block. So we had to come up with a way to mount that and still meet the code. We had a steel beam there. We wound up taking a steel L, welding it to it, making it stable, keeping it flat, and putting it in. These things are going to come up. Like I said, this is not an erector set. These problems, these issues are going to come up. They're all fixable. Some of them are easy, some of them are hard. You have to go in there with an open mind and not just figure I'm going to slap a 2x4 on. Got to look at it for what it is. Go ahead. Okay, hold it there. Starting to put cladding on the house, okay? I want to talk a second about waterproofing. We have a lot of issues in times with effervescence coming through tile. One of the ways that other vendors do this is they'll put when they have to build the wall out, they'll put a layer of tile on, and then they'll put another layer of tile over that. In this case, in order to build this out so it met at the appropriate point on the window, rather than building it out so far, put a layer of cement board on, thin set and anchored it in, floated over that, and then waterproofed again, okay? You want to keep this to a thin set application. You don't want it to be mudded, and you want to make sure what's behind here has been waterproofed. In this case, we waterproofed the whole thing, put the cement board, float it, waterproof it again, keep all the moisture from coming through, and then we put it on. The cement board is actually a good application because it allows us to meet the window exactly where we want it to meet the window. One of the things we had to realize when we ordered these windows is that we're going to have stone in certain parts of this building, okay? And the other thing we realized is there's things like the interior stair, which I'll go into in a minute, that we had no drawings on. We had a pretty picture on an architectural plan. It didn't say how to build it, how it goes together, how you're going to support it. So early in the project, and when I say early, I mean like before we ordered the windows, before we put the walls up, we knew we had to have something over here to support that stairway. So when we ordered these windows, the ones on the side here and here, we ordered them 4 inches narrower because we knew we were going to have to put a steel beam in there. We didn't know how, we didn't know exactly where it was going to go, but there had to be a means of attachment. To decide that about that window was 4 months, 6 months before we ever got the order on site. So those are the things you got to look at ahead of time. You got to build this thing in your head and figure out how you're going to do it. Okay. Let's stop one more thing. Waterproofing. You can see the waterproofing on a terrace. Here is the important thing. When we stucco the front and we put stone on the terrace, in the past we used to waterproof. We used to stucco the front, put the tile on the roof, and then patch it. It cracks every time. The other thing is in here, this part is cement board, this part is concrete. When you're doing this, make sure the waterproofing extends over the side and spans the joint between the two. Okay? So that if there's any movement, it doesn't crack along that line. Okay? What we do now is we install the terrace. We meet with the stucco contractor and the stone contractor. We determine how far that stone is going to overhang the front. Then when we stucco, we put a pencil edge, just like a drip edge you see underneath, between the stucco and the stone. It's only 1/4 of an inch, and when everything's done, with a nice caulk joint across, never cracks. Okay. Okay. We've gotten way ahead on this. Beginning parts of this go at a certain pace. Once the place opens up, it flies. Okay? This is where we have that shift between architectural and structural and interior designer. Okay? This is where all those things come together. Problem is the interior designer usually doesn't look at the structure. They usually look at the pretty pictures. If you look at this, I printed this off of one of the interior designer's drawings. And you'll see how the stair is extended 4 or 5 steps past the front of the elevator. The problem is there's a steel beam that runs right across, so they just took it upon themselves to take it out. Okay? So there's things that happen as you go with the interior designer. We'll go more into that. Okay? You see these curves? This was completely built. Then last week we got a new drawing that said we're changing. Okay. Sound bat in the walls. Okay? There's a difference between insulation in the walls and insulation on the perimeter walls. This is sound bat. This is just for sound. It has nothing to do with thermal. This is R7 insulation. Anybody who's ever come from up north is used to R30. This is R7. Hold on a second. Okay? When you put insulation on the walls, and what happens is every contractor correctly puts blocking across the bottom of the baseboard. Make sure this overlaps. Make sure this overlaps the baseboard. It has to go all the way to the floor or you'll fail inspection. Okay, hold it. One of the biggest things that happens once you finally get your interior design drawings is that the lighting schedule will completely change. Okay? What's in it, the amount of circuits, the amount of controls, they will completely change. This is lighting panels within the electrical closet. When we started this, we had 3 here and I think 2 upstairs. We added 2 more. Okay? And what happens is once you get the drawings from the interior designer, stop, go through them with your trades because it's going to change everything going forward. In a perfect world, you get them earlier, but in reality, you don't. Go ahead. Okay. What we're doing here is we're going to put lighting under around this part here. We frame the ceiling in for either plywood or stucco, and it's going to have a band that goes around that controls the lighting. This is specific to this job. You're not going to see this in other jobs. But when you do it, you have to think about, I have this piece of trim, how am I going to cleanly mount this in so the stucco is clean and it doesn't look like you rigged it. Okay? In this case, we have 2 pieces of L. It's going to fit between. Okay, we talked about the priming of the walls. What's the stucco do? Okay, hold up one second. When they're putting in windows, see this white? We call it fast flash. Okay? This is the first step of any window installation. This is actually waterproofing the surround before the buck goes in. And then once you put the buck in, you waterproof it again. Okay? We have never had a problem with windows because we do this, we do it right. Okay? Okay. Okay, waterproofing. They'll go up to the wall, they'll go over the lip, and they'll go down. Okay. This is the window I was talking about. We made 4 inches smaller. When they're done, they'll stucco over or stone over that metal pipe beam we put in, where the columns are. Okay, hold on a minute. You guys remember in the previous videos, we did the wall that was done with auger piles. Okay? Kind of hard to envision at that point what it would look like. This part is the auger pile wall. Everything here is standard. But in the end, it came out really nice. Okay, this is the cement board we were talking about. This is going to let it sit exactly where it needs to sit with the window. Remember, if you do this, if you build out one side versus the other, you'll have a pre-prepared box for a light fixture that goes out there. If you do this, you're changing your center on that column. Make sure whatever modifications you take into effect here, you look at what it affects on other areas. Okay? Okay. These are the lights I was talking about. When you alter the one side, you got to make sure those lights stay centered. Okay. Couple of things. We had talked, and I really need to stress this. We talked about getting things late in the project from the interior designer. One of the things I talked about was the stair. We asked for plans on the stair. This is what you get. You get an inspiration. This is what I want it to look like. Okay? At this point, you don't have a plan on the stair. You have no structural details. You have nothing. Okay? In addition, the plan they have, the image they've given you, doesn't quite correspond with the details on the site. For example, the stringer runs up the side, there's a glass rail that comes up with a cap. The stringer ties tight to the wall, then the cap hits the wall. You need the 1.5 inches by code. Okay? At this point, you really have to concentrate these things, and you have to get in touch with whoever you need to get in touch with to figure these things out. How are you going to build it? You need to get an RFI in writing back to the designer with your concerns. How am I going to handle this rail that needs 1.5 inches clearance and it's right up to it? How am I going to support this? How am I going to change where, you modify this? We had a criteria on this job where the owner didn't want more than 6.5 inch riser. And they had it at like 8 inches. Okay, so now we have to modify the plan. We have to modify the structure, we have to modify the railings, we have to figure it out. Plus the elevator, if you look at, I don't know if you can see it in this plan, but the elevator on this plan has a pivot door with like a 1/2 inch track. The owner wanted a industrial door, commercial door with the 2 doors that slide, which require a 10 inch track. It also requires support. You can't just put in a nice, easy glass frame with hardware. So we wound up having to go to the elevator company, get their specs for the elevator, get the openings in the field, put together drawings. This stairway elevator configuration wound up being a huge project in and by itself. And every time you do it, you get information, you put it together, and you send it out for approval, comment, or whatever. Constant communication with the parties is imperative, okay? Getting answers back from the designer, this is what I can do, this is not what I can do. Getting it back from the elevator company, does this pose an issue, do you have clearances? Getting it back from the structural engineer. How is the stair going to be built? How is it going to hold up? Am I mounting to that rail? All this stuff. These things are not insurmountable, but they do need to be addressed and they cannot be put on the back burner, okay? Things in here that came up, like we had a detail with a trough light. Okay, we're asking for specs on the trough light. We finally get the specs. The trough is 6 inches wide and the light is 2 inches wide. The hell, we order a sample, it's not going to work. Now we're well into the project, we don't have a light spec. So they provide another one, we order a sample. How is this wired versus the original? Do we need additional lighting panels? When you get things from the structural engineer and the architect, they're pretty much coordinated. When you get things from the interior designer, they're a wish list. And you have to figure out how to make it work and if it can. Most of the times, those things will impact time. Okay? The trough lights we're putting in, excuse me, trough lights we're putting in are a surface mounted over drywall. So I went to the town, I spoke to the building official. Normally I need lights in prior to my inspections. Prior to my closing of sheetrock, they want to see lights. So I got approval to put them in afterwards because of the application they are. All these things require you to go through it. If you throw it at the engineer, you throw it at the designer and say, figure it out and call me back, you're not going to get anywhere. You're going to be sitting. Earlier in these lessons, I said to you, don't ever go to an engineer, an architect, or designer and say, here's a problem, what do you want me to do? Go to them and say, here's an issue. I have 3 possible options. Give me direction on how you want to proceed. We received a lighting schedule this week for all the fixtures in the house. We were told that 2 of the fixtures in the dining room are 750 pounds each. How are we going to mount that? So we came up with this drawing. Steel plate, threaded rod coming down, sleeve through the duct, hook on the bottom, distribute the weight. This, will it work? I know it'll work. Am I going to take responsibility for it? Absolutely not. Okay? This goes to the structural engineer. He tells me, 1, is the concept right? 2nd, how big does this plate have to be? Will it span, does it need to span 3 joists? Okay? We can come up, we can be the teachers, we can be the directors. We can say these are options on how to handle these things, whether it be the lights, the elevator, the shaft.
When the designer said the 750 pound light, you take their word for it?
No, because 750 pound usually accounts for the crate and everything else that's in it. What a designer usually does is they give you this very simplistic thing, okay? I'll ask them a 0 to 10 fixture. I don't know if everybody knows. If it's 0 to 10 volts, you need to run a 3rd line, or when you dim it, it'll blink, okay? For the most part, I went through 3 months asking if it was 0 to 10, and after the 3rd month, they said to me, what does 0 to 10 mean? Okay? You guys know things from experience, they don't. They're not builders, okay? Everything you get, whether it be a light fixture, a piece of hardware, you have to look at it as if no one's ever seen it before. You have to look at all your parameters and make sure it's going to work. They are not looking at it as this practical. They're looking at it as it's a pretty picture, make it look like this. Okay? All these things we do are to keep the job moving. That's what makes us who we are. We come up with solutions and we use our experience. These type things are not things you learn overnight. They're things you learn over years of experience. That doesn't mean you specifically have to do it, but you're on a job where these things are being done. Figure out why they're being done. If you don't understand why something is being done a way, ask the super. If I show you this on a site, I did this in 1640. If I show you this if you see this going on a site and you have no idea what's going on, you're not learning anything. Okay? All the things that you see on a site are pretty much repetitive, but if something stands out there that you don't get, ask. Okay? You're going to learn just as much from watching somebody else do something you have no idea what it is and trying to figure out yourself. And in a couple of years, and in time, it'll come up again on the job. And you'll say, how did they handle this 2 years ago in 1860 when I had a heavy light? How did they handle it when I had to support the stair? How did they handle it when I had to build a frame around an elevator? You know, we had the back stair. We had the same situation. We had 6.5 inch limitations on the risers. In the previous lessons, I showed you we moved the steel out to get more room for the stair. Now we had a head height clearance. And they said, no, this isn't going to work. We wound up going back to the engineer, talking about cutting the slab back, making the recess in the slab the first step. It worked. Okay? Because we figured it out, we thought it out, we looked at the parameters. I can't move this, I can't move this, I can't move this, but I can play with this. Okay? No one's going to sit here and say, this is how I want you to fix it. They're going to say, here's the problem, make it work. Okay? Should it be our job? No. But the reason we get the work, the reason we have a reputation, the reason we can get things done in time, the reason we keep all these details working is because we attack it. We look at it, we figure it out. I mean, you could be so proud that you've come up with this great resolution. Do not put your name on it. Okay? I don't care if you do a full set of drawings of exactly how you're going to handle this huge structural issue. Give it to the engineer. He has to sign it. Okay? The hardest thing we do is balance liability versus performance. Okay? How we get it done is important. But we are not engineers. I'm not an electrical engineer. I'm not a structural engineer. Nobody here is either. Okay? If you come up with something, even if you know it works, get a stamp on it. Get an approval on it. Get an email on it. You have to get approvals on these things, even if they seem like the simplest things going. Because 5 years from now, something happens. I'm not saying it will, it usually doesn't. But God forbid something happens. I need to be able to pull out this piece of paper and say, see, this is okay. Okay? Questions? Okay. This moved very quickly since the last class. We've done a lot, and partially it's because of my absence. Going forward, you're going to see a lot happen very quickly. We had 20 sheet rockets at the site on Saturday. The difference between Thursday and Saturday is a different place. Okay? At this point in time, things move quickly. All right? So if you have time and you want to stop by and look at what's happening, if you want to see how we handled something, if you have something on your jobs that comes up, ask around. Did you ever see this before? How did you handle this? What happened?
Right, that happens to all of us too. He had small and asked me how to do X 3 years ago. I don't remember the Chris Ellis going to grad. Really, I don't remember the Carl going to be John Field. I don't remember the Marion knows the song. Okay? So we're a wealth of information. We're not an individual in this business. Okay?
If you take anything out of what we talked about today, take two things. One, we don't take responsibility, although we take the initiative to get it done, and we do not build erector sets. Good?